À tous de DDO, attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, top. Allumage P80 et décollage VV12 Aeolus. La propulsion est nominale. La trajectoire est nominale, la propulsion du P80 est nominale.
The DDO says all is fine on board. You saw Vega take off like a shot. I'm always amazed. It took her about 3 seconds to cross my computer screen here. 3 seconds, rising like an arrow. Surprisingly fast if you're used to watching the Ariane 5 liftoff. Ariane 5, of course, raises into the air much more slowly, weighs 6 times what Vega does, carrying 4 times as much propellant. Fine shots of her rising into the light clouds. All is well on board, says the DDO. Vega weighing 138 tons at liftoff, as she lifts off from French Guiana, beginning the 12th mission in her career. They call her the light launcher at 138 tons, but I guess that's relative. The first stage is burning now. She weighs 97 tons. 88 tons of that are fuel. Most of any launcher's weight is propellant in any system that we're using today. The first stage burns its single engine for about 2 minutes before being jettisoned. Maybe we'll be able to see that as our camera is tracking Vega, because visibility is pretty good. First stage is produced in Colleferro near Rome, then delivered to the French Guiana plant here, where it's loaded with fuel and transferred to the booster integration building. You probably saw some of that on the video on the launcher campaign. And having returned with a big smile on his face, before separation, is Martin Kaspers. So, how is it?
Incredible.
Tell us.
You see it, you feel it, and all the emotion that comes loose. It's great.
You're laughing.
No, it's not laughter. Yes, it's laughter, but also a cry.
Did you cry? Did you shed a tear?
I did shed a tear.
That's good. What impressed you the most? The sound, the speed, the light, what?
The light was so bright. I had not expected that from such a small launcher. I saw the Galileo or the Ariane launch, but this was much brighter than I had expected.
It's like Times Square out there. You can read a newspaper. All right, very good. Come down and watch a launch, folks, if you haven't already. P80, first stage separation has come on time. The second stage is burning. We're into the second stage burn, called second stage the Z23, Z for Zefiro. Burns its solid rocket motor for 86 seconds. Avio, of course, responsible for production, integration, and testing of both second and third stages.
Et propulsion du Z23, parfaitement nominale.
Vega's launching north, going into a sun-synchronous orbit. Why do we need that sort of an orbit? We need it for Aeolus, for the instrument, for Aladdin. We want to have a dusk-to-dawn orbit, so that we're always in the sunlight, and it's also the best way to measure the wind profile. And the orbit is called, they have a name for it, it's ball of yarn orbit, right? Explain that to us. It is basically, you go north to south pole while the Earth is rotating underneath of you, and in this way you peel off the Earth completely. You saw separation of the second stage. We're waiting for confirmation by the DDO of the third stage, ignition of the third stage. And there you are, right on time. And coming up next, separation of the fairing. All right on time. We can separate the fairing now because we've made it out of the atmosphere. Now, exposed to the elements, on the right, the round white section, that's your baby. Well, the baby is the cubicle and the white part of it in total, yes. So she needs no more protection from the atmosphere. She's getting her first taste of space. Of space, but not the first taste of vacuum. She was tested in CSL, Belgium. Right, we have a story about that coming up. First, we're used to seeing, here's a question for you, commercial satellites, 15-year lifespan, maybe more. 3 years for Aeolus. Why is that? Well, Aeolus is one of the Earth explorers, and it's also a technology demonstrator. And because of the small size, we have less fuel on board than the telco satellites have.
Right. So how much fuel, roughly?
We have about 266 kilograms of fuel on board.
La propulsion du Zéphiro 9 est nominale.
And the other thing is geostationary satellites. At geostationary, they use less fuel to stay in orbit.
Now, why is that?
Because they are geostationary, so they've got...
Because they don't go round in the ball of yarn.
Exactly.
Okay, very good. Another question for you. Aeolus is riding inside the Avum, that's the upper stage. What is Aeolus doing now? I ask you because sometimes satellites are launched on internal power, sometimes they're not on internal power. There are two schools of thought, and there are advantages for both sides. What's the case today?
Well, for Aeolus, we are on internal power since about 10 minutes before launch. So we made sure that our baby is awake and running its own internal processes.
And what's the advantage to that?
The advantage is that we know that the spacecraft is on. You can also switch it on in orbit through telecommand. But then, if you miss it, it will not go on. The disadvantage of what we're doing now is that you're in internal power, so you're draining the battery.
You're using some of that power.
Exactly.
Yeah, but I guess there's a case to be made for both sides. That's a hot debate in the space industries. As I see it, Vega means, excuse my Italian, Vettore Europeo di Generazione Avanzata, or Advanced Generation European Vehicle. The light launcher is the newest member of the Ariane family. Coming up on separation of the third stage. There you are, right on time. Confirmation from the DDO. Now what's left of the composite? On the left, the triangular bit is the Avum, triangular white bit. The gold box in the middle is what?
That's what we call the platform. So that's basically containing all the equipment to keep the satellite in the right orbit.
And you can still see the composite on the right of your screen. And, of course, the spherical, the oval, white on the bottom is the...
telescope. The telescope, which is part of the instrument, Aladdin.
Aladdin, very good. We'll have more on the instruments coming up later. We have been picked up by our downrange tracking stations. There's one here in Galileo. The next one is in the Bermuda Islands, where there's a NASA station. Bermuda will be tracking the launcher from the first Avum ignition to its cutoff on the first pass around the Earth.
Début de la manœuvre d'orientation avant le premier allumage de l'Avum.
You see the composite being spun up before the first ignition of the Avum. The first ignition, a long one, lasting about 8 minutes. There will be another one later on, a short one lasting about 20 seconds. Tell us about some of the other stations. I know there's some stations far north, Norway, Sweden, and Antarctica, that are going to be picking up the signal after the Bermuda station.
Yeah, so we have one telemetry station in Kiruna, Sweden. That is where we upload data for the control of the spacecraft. And then we've got two ground stations in...
There's the, while you're thinking, there's the beginning of the first Avum burn.
Okay, one is in Svalbard and the other one is in Troll, and there we download the science data from the spacecraft.
The Troll station in Antarctica will give us the final